Let's ensure in this clip that you understand the MVVM pattern. MVVM stands for Model View ViewModel. The MVVM pattern is the state-of-the-art pattern for WPF applications. Now let me show you what these three parts actually mean. Let's start with a view. In a WPF application, a view consists of a SAML file and a corresponding code behind file. For example, in our WPF project, the customer's view SAML file and its code behind file define a view. Also, the main window SAML file and its code behind file define a view. In a view, you create UI elements like, for example, a list view in which a user can select a customer. Then in your application, you usually have also a model. In our case, this will be a customer class. The customer class defines the data that our application needs, and it has properties like first name and last name. Usually, you have also a data provider class, which is in our application a customer data provider class. This class can be used to load and save customers. If the customers are loaded from a file, from a database, or from a web API, is implemented in this customer data provider class. The data provider class is not necessary for the MVVM pattern, but it is very usual to use one to load the data. And as we will have a customer data provider class in our application, let's include it here on this slide so that you understand its role. Now, with all these parts that you see on this slide, you could build the WPF application. That would mean that you would implement the user interface logic directly in the view, respectively in the view's code behind file with the file extension saml.cs. But if you want to apply the MVVM pattern, you create in addition a ViewModel class that contains the user interface logic. In this case, the class is called Customer's ViewModel as it is for the customer's view. This Customer's ViewModel class is using the model. It defines properties exactly in the way the view needs them. The ViewModel is actually a model that is made for the view. This is the reason why it is called a ViewModel. In case of the customer's app, the ViewModel can expose, for example, a customer's property for the view. You connect the view to the ViewModel with data bindings. To be able to bind to the ViewModel, you assign a ViewModel instance to the view's data context property. Then here the list view can bind its item source property to the customer's property of the ViewModel. So this is how everything is connected. Now, to load the customers, you will create in the next clip a load async method in the ViewModel that uses the data provider to fill the customer's property. In the view's code behind file, you will create an event handler for the loaded event that gets executed when the view gets loaded. From that event handler, you will call the load async method of the ViewModel to load the customers. So, we will create exactly this structure that you see here in the next clip. But before that, let's take also a look at the advantages of MVVM. With MVVM, the ViewModel is UI independent, like the model and the data provider. The fact that you have the UI logic in a UI independent ViewModel class leads to the advantages of MVVM, which are maintainability and testability. The MVVM pattern increases the maintainability as it separates the UI and the UI logic. The UI logic is in ViewModels, and you can focus on that logic without having to bother too much about the user interface. A ViewModel is a UI-independent class, which makes it a perfect target for automated unit tests. This means MVVM increases also the testability of your application. If you want to learn more about the unit testing of ViewModels, please check out my course WPF and MVVM Test-Driven Development of ViewModels. Now let's create and use a ViewModel in the customer's application.